Good morning, everybody. Welcome to Turfgrass Epistemology. My name is TravisShaddox. If you're here, you're interested in knowing how we know what we know about turfgrass science. If you're new to the channel, welcome. If you're a seasoned veteran, thank you for returning. We're going to be going over a video today about soil test comparisons. I noticed some trends online where I see a lot of YouTubers talking about comparisons between soil tests. And we're going to go over that today. Okay. Real quick, on yesterday's show, my technological IT incompetence reared its head again and the microphone went out. But thankfully, it only went out for a couple minutes. I will say this to the members. I apologize for that. And I have come up with a solution. So I didn't quite get it put in this morning, but it'll be instituted by Thursday, I hope. So there should be no more problems with my audio. It's embarrassing. Can't even figure out how to get the microphone to work. And then real quick, I keep forgetting to mention, I finally figured out how to open up a Facebook account and an Instagram account. If you're a member of the YouTube channel, don't fret anything. You're not missing anything because it's the only thing I'm putting on over there. Those accounts are the videos like the short clip videos that you're seeing on the YouTube account anyway. But I wanted to see if that might help, spread the word about information that I do here for people that don't come to YouTube. So Facebook, I think, is Turfgrass Epistemology, and Instagram's Turfgrass Epistemology. Once I set it up, I don't really go over there. So I don't know what's going on over there. I just know that there's a system set where it automatically posts to those platforms. So for anybody who's on Facebook, which I didn't realize there's so many like YouTuber, like lawn care people on Facebook. I didn't realize that. So if that helps you all, access information, then I hope it does. I opened it up to help if it needs help. So anyway, and I think that's it. So let's get started. This is a short video. It's only 15 minutes. I'm going to show this video, and not just the content in this video I want to talk about, but just in general. I've seen several videos here recently about people comparing soil tests methods, and you really want to refrain from doing that for several reasons. I'm going to show at the end of this video, after it's over with, I'm going to show some scientific articles, just a few graphs that will hopefully drive home the point that even valid soil test methods don't always correlate. I mean, there could be a soil test method, like let's take Olson, for example, that is very appropriate to use with certain soils, depending on the pH. That may or may not correlate at all with Malic 1 or Malic 3 extracts, or Bray might not correlate with Olson, or whatever the case might be. Malic 1 may or may not correlate with Malic 3, and they're all valid extracts. The problem with what I see online is they're comparing valid soil tests with invalid soil tests. That's the problem. You don't want to do it even with valid soil tests. You need to know a lot more about the system before you just start comparing numbers among, let's say, Malic 1 and Malic 3. That's not too much of a stretch there, but when you go from Malic 3 to like Olson or something like that, you don't want to just start comparing numbers and seeing if there's a correlation. There's been plenty of work done on that. Sometimes it works, sometimes it doesn't. But it doesn't negate the value of either test. Both of them could be completely useful. Okay. So anyway, we'll get to that at the end. So let's get to it. This video today comes from us from a channel called Mr. Ferguson Lawn. Mr. Ferguson Lawn. The title of this is Results Comparing RX Soil versus Yard Mastery Tests DIY. Okay. So let's get into it. I don't know who this person is. Sometimes I wonder when I go over these videos if like the person I'm going over is actually a member of my channel. I don't know. I don't want to offend anybody, but just keep in mind that it's nothing to do with this person. I don't know this person, but when it comes to the content, I will unapologetically and very assertively and borderline aggressively attack any truth claims that are complete nonsense. But it has nothing to do with the person. I have no idea who this person is. He may be great, but what he says, if it is nonsense, I'll call it out. Okay, here we go. If there's any issues with the audio, please let me know ASAP. I'll do my best to adjust it.
So as mentioned, here we are. We've got our 2 soil tests and we got our probe. Now, as soon as we finish filming this part, we're going to take this soil test probe. If you're totally unfamiliar with how to do a soil test, we're going to go to different parts of our lawn. We're going to shove this bad boy in the ground. We're going to collect the dirt right here, dump it out into a bag. We're going to mix all that up, take out the stems, the roots, the grass, get as much clean dirt as we can from all parts of our lawn. We're going to mix it all together and distribute that same bag of dirt within the 2 soil tests. So there'll be no difference in collecting 2 different places for the soil test. It's all going to be one dirt, one bag, split up into these 2 soil tests.
Okay, so the introduction I skipped through because he had a little 1 or 2 minute introduction that was just saying hello, which is fine. But on the screen here, he has the yard mastery test, which is the same thing as my soil, from what I understand. I could be wrong on that. I believe it's the same thing as my soil. I'm not very... I don't know much about those tests in terms of how they operate or how the companies operate. And then he has it compared to another test that is called RX soil analysis. I don't know RX soil, but I will say that the soil test report from this particular home mail kit seems identical to another soil test kit. And I don't know if they use a similar platform or company does both of them. I don't know how it works. But what we have here is essentially the RX soil test kit, which I think it comes from a normal soil test extract. And they have it in Malik 3 in parts per million or pounds per acre. You can change between whatever unit you want, which we went over the other day about not doing that unless you know the soil test depth or the sampling depth. But that appears to be, the RX test appears to be a valid soil test. The yard mastery test is a flawed test that may or may not have any value in turfgrass science. But because there's been no published correlation on it at all with any nutrient at all, as far as I know, there's really no good reason at all to use that test or to rely upon its results to apply nutrients to turfgrass. So we have apples and oranges. We have a comparison of, say, the heliocentric model of the planets and Earth compared to the flat Earth model. And well, they might correlate. Well, what happens on the heliocentric model correlates with the flat Earth model here? It might. It's irrelevant. Doesn't matter. The heliocentric model is the model that is an established fact. The flat Earth model is ridiculous and not proven at all. And that's what happens with these 2 tests. The Malik 3 extract or any other valid extract is proven to be accurate and proven to be correlated well. And the ion exchange bead has not been shown to be well correlated. And as far as I know, there's no published work at all in turfgrass science on manganese or magnesium or any other element besides nitrate on turfgrasses. So we're starting off with a false equivalency. They're equating these 2 tests as if they're somehow, both valid. And they're not valid. Only one is valid. So we'll continue, and we're just starting off on the wrong foot from the beginning here. Okay, we continue.
So obviously the first one we're going to do is yard mastery. I'll put the price somewhere to the left here or the right, and it's around $39, $40. And in this kit, when we open it up, this one is, I'm familiar with this one because I've done it before. This is a product, as someone had mentioned a while back, this is a product of My Soil. So if you're familiar with My Soil, up here on the top, powered by My Soil, there it is. Yard Mastery is just partnered with them. And so you register your kit right here. They give you an envelope in this one to send off your sample. And then inside you have your cup. When we collect all of that.
It's talking about Yard Mastery, joining with RX or whatever. I will say there's a saying that I like to go to. It's not exactly relevant to this, but even thieves like to do business with honest men. But sometimes they like to do business with each other. Just saying, okay? It doesn't make any difference who does what with whoever. If what matters is that the soil test itself has not been proven to be valid. And so it doesn't matter what kind of brand you have on it or what sort of stamp of approval you have on it, or what company's doing it, and it doesn't make any difference. What matters is whether or not there's any evidence to support its use. And right now there is none as of today.
Dirt, as we just mentioned, we'll get our cup. We will take that scoop of dirt and we will put it in our liquid here that we have from Yard.
Yeah, and it's just so the people who may not be familiar with this test, there may be some people watching for the first time. This is what I'm talking about. This cup on the screen, the gentleman's showing a small plastic transparent cup with a white plastic cap on it. In that cup, there's, I assume, deionized water with a little capsule in there, okay? And the idea is that you get a scoop of soil, you sample your yard and you mix it all up, and then you get a scoop of that soil. And that scoop volume, when you put it into this container, this capsule, it's the appropriate volume to volume ratio, I suppose, is what they do. And then when you put it in there, you seal it up and you send it in. And in the meantime, that capsule has ion exchange resins inside, and it will begin to absorb some of the nutrients that were in the soil or on the soil onto the ion exchange bead. When it shows up at the lab, they process that ion exchange bead and remove what was absorbed. And then through that process or through that assay, they can determine certain parts per million of the nutrients. All of that is A-okay with me. I have no problem with any of that. The sampling method, the mailing method, I don't care if you sit that soil in that cup for an hour or 50 years. It's irrelevant to me. What matters is whether or not that method, whether you used 1 hour of extraction, 2 hours, 2 days, 1 week, 3 years, whether or not that time frame and that method has been properly correlated with the turfgrass response to the applied nutrients that you are then recommending from the test. Okay, that's what I want to know. You could sit that soil in that cup for 1,000 years, and if you do a correlation and it's strongly correlated at that 1,000-year time frame, then sit it in for 1,000 years. You could sit it in there for 50 seconds. It doesn't make any difference. What matters is, does that time correlate that's been in the solution cup? And you could say, well, we're going to mail this in. Some people are going to mail it in and it's going to be there in a day. Other people are going to mail it in and it's going to be there in 3 or 4 days. That's a different time extraction. It doesn't matter. What matters is whether or not they have a time, because sometimes some timed extractions will maximize at a certain time and then not change. So did the timed extraction maximize out at, say, a day, whatever the least time frame is for their method? And then did it change at all from 1 day to 3 or 4 or 5 or 6 days out? If it didn't change, then it doesn't matter when they send it in. But if it did change, and if the correlation changed based upon the amount of time that it incubated in this cup, then we got a huge problem. But all of that is irrelevant because there's no correlation at all with any of this stuff as far as I've seen. It doesn't matter whether it's been in there for a day or a year. There's not been any published data on copper or boron or zinc or anything like that when it comes to this test in the scientific literature. I don't mean ion exchange membranes. I mean this test is what I mean. So until then, all this debate back and forth as to, well, it's what if it lasts for a day, or what if you incubate it for a day? It's all irrelevant. Doesn't make any difference. Okay? We continue.
Mastery, and that is what we're going to mail off on our envelope here. So that is that for Yard Mastery. Pretty self-explanatory. Now this one I saw online and decided to use a different type. Now this one's called Soil Analysis from Lawn, Gardens, and Landscapes. Here is our sample number. It's called RX Soil. So it came in this package. I got my address on the other side, so I'm not going to flip it. But basically, they want you to reuse this bag here. So we're going to have to send it back in the bag that it came in. Actually, that is completely incorrect. You do not reuse this bag that it came in. There's actually a return label on the bottom of the box that I just showed you. So I figured that out the hard way, but you put your sample in the box, place the box in your mailbox, put your flag up, and they'll come pick it up and ship it right back to RX Soil. Easy peasy. So it is a reused bag, but you can just throw that away. When you open it, this is what you see on the inside. Instead of a cup, this one comes with a fill the dotted line. It's got that same number from...
So he's showing, for those listening, he's showing a plastic bag, just a Ziploc bag looking thing with the dotted line on there. So this is, I don't really like taking samples with a Ziploc bag for many, redox reasons. But I think if you're going to put it in that bag and you're going to put it in this cardboard box and remail it back in, I think that would probably be okay as long as it didn't sit in there for a long time and start fermenting and having some changes going on. Because it's in the dark and it's probably not going to, it's going to have some things going on. But I just don't like Ziploc bags. And that's the reason you see soil test bags in like a hard, not a hard, but one that doesn't let light in. But I think they're going to put it in this box and mail it off, so I think it's okay. But what I'm getting at is this appears to be a proper, valid test to me, at least on the surface. This test, along with, I think it's soilkit.com, also has a similar process. You can get some of those packages or soil tests at some of the box stores, from what I understand. That's what I've been told. And those are valid tests. That's a valid home soil test kit. So the problem is that there are some valid home test kits and some that are not proven at all. And it's unfortunate that the average homeowner will have no clue which one's valid and which one's not, or which one has evidence to support it and which one doesn't. But this is why I'm showing this. This one, where you're taking a sample, putting it in a Ziploc bag and mailing it off, they're going to do an extraction on that test, I assume. And the other one, where you're putting it in water, you want to avoid those tests until there's evidence to support their use. And as I've said before, I don't demean or diminish the potential of those tests. I think those tests probably do have a place, and they may, exceed our correlation that we have on our existing test at some point in the future if we get enough research done on them. There's potential there. But until it's done, there's no reason to use it. It may be completely wrong. So
the top, I'm sure the same number. So you've got a little more to fill than the cup from Yard Mastery. So this will require a little more dirt. And so we'll fill that up to the line. And it says right here, collect your soil, bag your soil, send it, which is talking about in the envelope that I just showed you. And then you track it on this website. So all it is in this box is a bag and instructions. So it's somewhere around the $34 to $39 price point as well. So these are the two soil tests we're going to test. And the main point of this is, I've questioned in the past. I was like, I don't know, Yard Mastery or My Soil, if what you're showing me in my soil test is totally correct. And I could be totally wrong. And I've heard others say, yeah, it may not be correct. They can be wonky. So we're just doing a simple test. It's not to prove Yard Mastery sucks. It's not to prove RX Soil sucks. It's not to say that one is better than the other. We're simply taking the same amount of dirt. We're sending it to these two different companies and seeing, do we get the same results?
So, it's fine. It's a decent, introduction to what he's going to be doing. But I just don't think, and I could be wrong. There's a lot of members on the show today, or in the chat today. Good morning, Internet Surfer, and Joe, and Turf Nerd, and Transition, and Connecticut Chuck, and Gray, and Valerio, and Rob. There's a lot of people here today. I could be wrong, but I suspect that the average homeowner, the average turf manager, just doesn't even have any idea that one is valid and one is not valid. I just don't think they know. And when it gets to the homeowner level, you're many levels removed from the knowledge of turf science when you get to the homeowner level. So I don't think homeowners have a clue that one is, just not evidence-based. I want to say it's a con. It might be a con. It's hard to know. Whether there's no evidence to support it, and they're continuing to push it and convince people to use it. So I guess it meets the definition of a con job. But I'm not comfortable saying that in this case, because there may be something there. Like I've said before, it's just there's been nothing published, so there's no good reason to believe it. Whereas the other one, as you'll see, is a perfectly fine soil test. There's nothing wrong with it. So it's like saying, it's just, we don't see if there's a comparison between these two. I don't care if the R squared is 1.0 between these two. One is completely useful and valid, and one is not. Or one hasn't been proven to be, I should say. Okay. Oh, whoops, on the wrong thing here.
Is it close? We'll find out when we get the results. So I'm going to go ahead, as I mentioned, I'm going to get my probe. I'm going to collect my soil from around my yard. I'm going to get that bag. I'm going to distribute it. I'm going to get these in the mail. And the next time you see me, we will have our results, and let's go over that. And for you, that happens right now.
Yeah, so let me expand a little bit on what I just said when I said I don't care about the R squared being 1.0, and because one's valid and one's not. The difference between, or the definition of knowledge is a justified true belief. Okay, so he could be right. Okay, but so for this test, it could be correct, but it might not be knowledge because it's not justified. Let me give you an example. I may have given this example before in the past. I don't know. I may end up putting one on the back of my. In fact, I will. I'll buy a little gumball machine and stick it up in the back so it reminds people of this analogy. Let's say you had a gumball machine, and in the gumball machine were red, white, blue, and yellow gumballs. Okay, and I asked you, how many yellow gumballs are in this gumball machine? And let's say you said 32. And come to find out, there is exactly 32 gumballs in that gumball machine. You could not be said to have had knowledge of that. You could be correct. You were correct that there was 32 yellow gumballs in that machine. But you didn't have a justification for that. You just got lucky. Okay? You were correct, but because your answer was not justified, it was not knowledge. It was not a justified true belief. You believed it was 32. It was true that it was 32, but it wasn't justified. So how would we go about determining whether or not your belief was justified? Or say in a future request. So now how many red gumballs are in that machine? Well, in order for your answer to be justified, you could then test it. You could take the gumballs out and start counting them. And then you said, okay, there's 16 red gumballs in this machine, and your answer would be knowledge because it would be true and it would be justified. So that when we get back on soil tests, when they use these tests, the response or the recommendation or the interpretation could be correct. But the reason it's not knowledge and the reason it's not a valid test is because it's not a justified true belief. The justification comes from evidence. You have to have some way to count the gumballs, for example. You have to have some way to actually correlate the values on this test to a turf response. That's the difference that's why I'm saying one is valid, the RX soil analysis kit, because we've gone out and we've tested it. Not that particular box, but I mean the method they use. They mail it to the lab and they extract it. Whereas this one has not been tested. So anything that might actually be true could be completely coincidental, or it could be true, but we have to justify that belief. And because of that, we have to do a test. Only then can it be knowledge, and only then would I consider it an evidence-based soil test kit. Okay? So that's the reason I don't care whether it's a R squared of 1.0 or not. It could be exactly correlated, 1-to-1, exactly, right across the board. And I still wouldn't use it because you might have just accidentally guessed 32 yellow gumballs in the gumball machine. Okay?
All right, so welcome back to Inside at my computer. We've got our results from our soil test. For you guys, it was a matter of seconds. For me, I want to compare this.
So for those listening on the screen, he has two windows open. One window are the results on the left from the RX soil test kit, and the one on the right is from the Yard Mastery My Soil test ion exchange membrane kit. And he has bar graphs and he shows numbers and values. Now, I want to point out that on the left, the reason I'm saying I think that this is either managed by the same company or perhaps even, I don't know, owned, or maybe they use the same platform. I don't know. Or maybe it just comes from Waypoint the same way. I don't know how it happened, but that on the left, the one from RX Soil, the feedback, the report, looks virtually identical to the soilkit.com report. And I know that one goes through Malik 3. And on this one, you're going to see on the left, it'll have like optimum ranges and stuff, but it has parts per million. So I'm almost certain that this is a Malik 3 extract on the left.
Again, we did Yard Mastery, and again, I'm making this, about a week or so after sending it off. So I apologize, I don't know what the first clip was because I haven't reviewed it. Lazy Mr. YouTuber here. But we got Yard Mastery and we got RX Soil. The results literally came at the same time. So as far as sending it off, I can't remember the exact date. Probably should have kept up with that, but it was roughly about 5 days, and I had my results. 5, 6, 7 days, roughly 5 to 7 days, we'll say. They were the same time. As soon as I got these, these. I got the one for Yard Mastery, both online. We're not going to go into all the details. So the timing, they were both easy. They both were sent off. They both came back in relatively the same time, cost the same, no issues there. So let's kind of look at, what does one soil test say than another? Now,
yeah, it doesn't make any difference. I'm going to show you at the end. It's completely irrelevant. It doesn't matter whether they correlate or not. One could be completely not correlated to the other, and both could be valid tests. Or they could be exactly correlated and one be valid and one not. Just like I mentioned with whether or not your belief is justified. It could just be sheer luck. Okay.
You guys may be familiar with Yard Mastery, so let's look over here more at the RX soil. They have a little bit of a different format here. You can see that they tell you one of the things, our pH is 6.8. They tell me that organic matter is 3.6%. Your level's optimum is 5, so we're a little low there according to them. Our capacity to retain nutrients, never heard or seen that before. Optimal range is 11 to 16. We're 8.8, so we're low.
Yeah, I wish they wouldn't put that on these tests, because an optimum range of CEC 11 to 16, how the hell do you know that? There are thousands and thousands of acres of really, really high quality turfgrass grown on soils with a CEC less than 11 is what they have on this test. I'm not sure how you come up with an optimum range of 11, or the lower range is 11, but they have it on here. I wish they wouldn't do that unless they have some sort of publication or evidence to support it, but it is what it is.
I don't really know what that means, and they don't really go into any more detail there.
Well, I'll tell you what it means is that, they call it the capacity to retain nutrients. I think that's just a layman's way of, they're trying to say it to a homeowner, to a landscaper in a way that would, inform them of what CEC actually is. CEC is a cation exchange capacity, and it gives the reader an idea as to the soil's ability to retain cations. So they say capacity to retain nutrients. It's specifically to the cationic nutrients like calcium, magnesium, potassium, things like that.
When we come over here to our phosphorus, we're 61.
So this is what I'm saying. So on this test, it says optimum range 42 to, it looks like 68. I don't know if you can see that on the screen or not, but 42 to 68, and potassium 89 to 107 parts per million. I don't know where they get that from, but if I'm assuming this is a Mehlich 3, but even if it's a Mehlich 1, I don't know where the hell they get that from, because they sure as hell didn't get it from the literature, because the literature is nowhere near that number on phosphorus, on either Mehlich 1 or Mehlich 3, 42 to 68 parts per million. The critical limit for phosphorus on Mehlich 3 is almost in the single digits. I wouldn't want to be down that low, but certainly nowhere near 42. That's at least twice the level of the critical limit. So I'm not sure where they get that. Potassium, 89 parts per million. Again, I don't know where they're getting it, but it's not from the literature. You could make a really good argument that the critical limit for potassium is maybe around 50, particularly if you have poannual green, something like that. But reality is it's probably much lower than that for the majority of turf scenarios. But on low cation exchange capacity greens, sand-based greens, and you're looking with some winter kill issues, I don't think you'd want to grow poannual at less than 50 parts per million potassium. But they have it at essentially 90. So I don't know where they're getting this from. This is one of the problems I have. I don't have a problem with the sampling. I don't have a problem with sending it in. I don't have a problem with the numbers they give back in terms of the values. It's the interpretation of the values and the recommendations from that are completely flawed. And this is the test that's the evidence-based test. This is a valid test. The numbers are what I'm saying are valid. These recommendations and these interpretations are what is, I don't know where they pull these out of. Pull them out of thin air. I have no clue.
Potassium, they say we're 72. And so let me see. And normal is 89. So they're saying we're low on this test with our potassium.
Yeah, so there's an example of a valid soil test informing the end user that he probably should apply some potassium when his potassium is 72 parts per million. I encourage anybody listening or watching to send me any refereed paper in the history of turfgrass science from any reputable turfgrass journal that shows a beneficial turfgrass response to apply potassium when it is 72 parts per million or greater. It might exist. I've just never seen it. So until I see it, I just don't have any good reason to follow that recommendation, and neither should you.
Calcium, we are a little bit low with our manganese. As you guys know, I was crazy high, magnesium. Magnesium, we are optimal.
So he's reading this, and he's reading it from the report, but he's reading it, the report gives it in PBS, percent base saturation, and you do not want to do that, as we've gone over this many, many times. Do not read or apply calcium or magnesium or potassium based upon base cation saturation. It's not the right way to do it. It's a very expensive, wasteful way to do it. You want to do it based upon the critical limit and the extractable quantity. Okay? Let me answer a question in the chat by Joe. Joe, do you want me to call you Joe or Joseph? I don't want to mispronounce what your name is, what you prefer to go by, but let me know in the chat if it bothers you if I call you Joe. It says, hey, Doc, speaking of critical limits, I asked UConn for critical limits, and they gave me their optimal ranges. Do these low and optimal ranges seem in line with the critical limit? Oh, that's a really... let me back up and read the question more clear, Joe. It's a very good question. So he says, speaking of critical limits, he asked University of Connecticut for the critical limits, and they gave me their optimum ranges. And then he's asking, does the low end of that optimum range align at all with the critical limit? And strangely enough, or maybe coincidentally enough, oftentimes they do. Yes. In fact, if I can get it open here without screwing up my microphone, I keep a cheat sheet here. This little cheat sheet is underneath my little pad here on my computer. And what this has Penn State, Clemson, University of Florida, University of Wisconsin, Kansas State, Texas A&M, North Carolina, Utah State, and all these other things. And it has their recommendations on phosphorus limits with the various in the various soil test extractants that they use: Mehlich 1, Mehlich 3, Bray, Olson, and so forth. And if you look at, say, and they have them listed as very low, low, medium, sufficient, high, and so forth. And if you look, for example, at, say, let's take, I don't know, where's one that, Texas A&M. They have the medium from 0 to 20. So obviously you wouldn't want it to 0, but the 20 is right, pretty much in line. They don't have anything on the low. The 20 is pretty much in line with the critical limit. When you go to, let's say Mehlich 3 from University of Wisconsin, they have the low from 6 to 10. Now, Wisconsin's a little different because that's where a lot of the work's been done. And so Dr. Soldat knows more precisely what it is. But he has the low between 6 and 10. So that 10 is probably, even the 6 is probably lined up with the critical limit. I wouldn't want to be down that low, but that would be the critical limit. Clemson has Mehlich 1 less than 15. So the 15 is, probably a little bit on the low end, but for Mehlich 1, it's fine. So very good question. And yes, so if you have ranges, you're better off going with just looking at the low number. In this particular example, it doesn't work because they have potassium listed at the low range being 89. But in many cases, the low is oftentimes aligns with the critical limit, or it comes very close to it. Okay, so I wouldn't say I would just jump in with both feet and follow that recommendation, but I would say you'd be more in line with the evidence following that recommendation. You'd be more in line more frequently than you would be if you follow like some other value above it, for sure. Yeah, excellent question. And then, so you have calcium. So you listed the values. Calcium at 1,800 parts. Well, that's not close. 1,800 pounds per acre is nowhere remotely close to the minimum on calcium. Magnesium, 175 pounds per acre. Yeah, those aren't even close. Phosphorus, 6 to 20. That's not bad. Pounds per acre. And potassium, 100. Yeah, so the potassium one's close. The phosphorus and potassium, Joe, on the minimum, on the low end of that range, are very close to the critical limits. I would go with that. I'd feel comfortable with that when you convert it to pounds per acre. Parts per million. But the calcium and the magnesium are nowhere remotely close. The calcium, I wouldn't start worrying about calcium in terms of reaching the critical limit till you get down in the 300 or 400 parts per million. And magnesium, we don't have a really good numbers on magnesium, but magnesium is probably somewhere around the 20 number, 20 to 30 number, something like that. I wouldn't have a whole parts per million Mehlich-3, and that's 175 pounds per acre, so that's nowhere close to it. But in general, you will oftentimes see a relationship between the lowest range value being similar to the critical limit. Yeah. But that's just going to be just coincidental, I would say. Oh, and Yukon uses a modified Morgan. Okay, so I can't speak to the... So let me just back up and erase everything I just said. I can't speak to the modified Morgan extract with the values. I apologize for the last 2 minutes. Modified Morgan's different than the Mehlich-3, and I can't always correlate those two very easily at all. And neither can many other people unless you have a lot more information. So, Chuck Benzing says it looks like RX does not report organic matter or ENR, whereas Waypoint does. Is that significant? I don't know, Chuck. I'm not sure. Yeah, I'm not sure about that. But anyway, good question for both of you guys. Appreciate the questions. I'll do my best to answer them. Okay, here we go. We continue. But anyway, he's showing, back on the video, he's showing calcium, magnesium, and the percent base saturation. And you don't want to do that. And now he's going to go to sulfur. And I will say the one thing that I have some confidence in is sulfur on Kentucky bluegrass at least. The number is going to be somewhere above the single digits. As long as you're in the double digits, Mehlich-3 sulfur, you're probably fine. And this one, he's saying that they're going to say that the sulfur should be at least 29, and they're at 13. So here's another example where the extractable value, which is 13, is sound. I have no problem with that. But the recommendation, the interpretation says you need to apply sulfur or sulfate sulfur up to 29. And I just I'm not convinced that you would actually see a beneficial response in the turfgrass to applying a form of sulfate sulfur when your sulfate sulfur is already 13 or greater.
Sulfur, it does say that we are low, and that's interesting because I think we have a difference there. We'll look on the other test. We'll have to compare here, zinc and everything else. So our manganese were high, and it even says, which just threw me off, it says our iron is 11 to 51 parts per million.
Yeah, I wouldn't have a whole lot of confidence in for turfgrass science. Okay, I wouldn't have much confidence in the zinc levels, knowing or the interpretation of the zinc levels, the iron levels, the copper levels, the boron levels. There's a tiny bit of information on manganese, but again, I wouldn't have a lot of confidence in it. I know some people like to throw out the 30 parts per million Mehlich-3 number. And there's a paper on that. I can go over that if you want me to. But I'll just say that there's a lot of turfgrass grown on soils with manganese levels well below 30 parts per million Mehlich-3, and it looks perfectly fine. The 30 parts per million Mehlich-3 manganese has to do with a root rot correlation between the manganese level and a disease, which obviously that paper shows that. It's a valid paper. But when it comes to like the critical nutrient level of manganese in the soil, I wouldn't have a whole lot of confidence in any of these ranges because I just haven't seen a lot of information on that in the literature.
We're at 133. It says my iron is through the roof on this test, which I thought was odd. So there is the graph, and it didn't do nitrogen. As you guys know, nitrogen fluctuates. So not bad. Just looking at my soil, not a bad soil test. Now, let's go over to Yard Mastery. Over here, Yard Mastery said that our pH was 6.5 compared to 6.8.
Let me just mention here is that I've seen this before where, the pH of the Yard Mastery one is 6.1, and this one they're going to say is close. But the pH of the Yard Mastery is 6.1, and the pH of the soil sample I sent in the university was 6.9. It doesn't matter. It's irrelevant. The process in the lab where they take the soil sample and they measure the soil pH, that process has been correlated, and we know roughly what the pH should be in terms of our risk. Okay. The method that they're using with this little capsule could be completely or even more accurate and more correlated with the turf response, but we don't know because no one's ever published it. In other words, they're measuring pH in a different method. And it doesn't mean it's wrong. Here I am defending these non-evidence-based soil tests. It doesn't mean that it's wrong. It just means that I'm not convinced that it's right. That's the issue. And until I'm convinced that it's right, I wouldn't use that soil pH method where they're putting it in the capsule and mailing it in with this little thing of water. Show me how that method and the pH derived from that method is well correlated, and we can have some sort of predictive ability to give a recommendation. Because I can show you paper after, I've shown you dozens of papers of the soil test method and the pH method used in the labs through the proper method, okay? Or through the normal soil test method, but not from this other capsule method.
It's pretty close, pretty much the same. So, in far as our two tests, pH is totally close.
And it doesn't make any difference. They could be dead on, and one is valid in terms of evidence base, and one is not.
The main things that I found that was different was our sulfur. It said we had 16.15 on yard mastery, and we're at high. We're high on sulfur, where over here they said we're at a 13 and their parts per million is 29 to 36. So we were way low on this test. So,
and now just, again, I like sulfur because it happens to be the paper that I'm writing right now. Been writing it for like a year. I'm waiting for some more data to come in, but it's going to get done eventually. I can say with a fair amount of confidence, I don't like saying they don't have or making a negative claim because you can't prove it. But I have almost zero confidence that they've done any work with sulfate sulfur in terms of this capsule test and knowing what the range should be on turf grasses, on warm season turf grasses, on cool season turf grasses. I don't want to say they haven't done it because I don't know, but I've done it myself through the normal method, Mehlich 3 method, and in field studies, I've done that. And there's a good correlation. That's the reason I have confidence. As long as you're in the double digits sulfate sulfur Mehlich 3 parts per million, you're probably fine. But on this method, the other test, I have no clue. And I'm pretty confident. Well, I should say I have no confidence that they've actually measured that, because I know how hard that is to actually go do. One, you actually have to find a turf grass growing on a sulfate deficient soil that is showing signs of sulfate deficiency. You have to find that somewhere. And when I found it, I hauled ass out to the sod farm, and I can bring him on here and have him tell you about it. He probably thinks I'm crazy because I was like, please don't apply anything to that field. Please give me a section of it, because it's not exactly easy to find. When you find it, you have to take advantage of it and put a study out there. And sure enough, that's what it was. But that doesn't just show up every day. It's not very common. It's not like nitrogen deficiencies where you can pretty much do it wherever and you're going to see a response. You have to find the location. Then you have to do it for multiple seasons. Okay. And it's not as easy as, oh, well, this is the range and this is kind of what we find in corn. This is kind of what we find in soybeans and alfalfa. It's not the same.
Sulfur, big difference in the test here. Same thing with iron. Over here, Yard Mastery has my iron as low, 1.6 to a 4 and 11 scale, and we're 1.6, that our iron is low. When we come over here to this test, 11 to 51 parts per million, we're at 133. They have my iron as super high.
Yeah, I wouldn't worry about iron at all from either one of these tests. Like I mentioned, I wouldn't have much confidence in really hardly any micronutrient on a soil test. Any soil test, really. I wouldn't have a whole lot of confidence in that. Iron, as I mentioned, the plant takes it up from exuding either hydrogen ions or phytosiderophores, which are natural chelating compound, out of the root, right at the rhizosphere of the root. So there's no iron being applied to the Amazon forest, and all those trees are getting iron from somewhere, okay? And all that iron out there is oxidized. Those are oxasols in Brazil. But there's a little bit of exudation right around the root tip where the iron's absorbed, and that's all the plant needs. The plant has evolved a method to take up the nutrients that it needs within reason. Okay, so I wouldn't worry about an iron deficiency on a soil test because, one, there's not a lot of correlation, but two, the plant will take up most of its nutrients, most of its iron on its own through exudation and through slight acidification or chelation of the iron right at the rhizosphere area. And there's just not a lot of correlation between any soil test iron level and the turfgrass response to it. So I wouldn't worry about it.
So for sulfur and for iron, that is the biggest things I'm seeing in the comparison of the soil test. But the iron as well. The iron really throws me off because they're telling me I have way too much iron. Yard Master telling me I don't have enough iron.
Okay, well, I'll help you, Mr. Ferguson. It's throwing you off. I agree. It's probably throwing a lot of people off. Just ignore it. Ignore both tests on iron and it won't throw you off. Just forget it. Okay? Hopefully that helps.
So that one confuses me. So if any of the grass factors watching, hey, you guys, you know those dudes over there, comment below. If you have your ideas, let me.
Oh, I don't know if anybody commented below. Did anybody comment below? Maybe I should have looked. Well, I'll read it after I'm done with the video.
Let me know below. Ultimately, to wrap this up, because I don't want to talk forever, we've got a good pH. We've got a lot of our levels optimal on both tests. So overall, you know, our NP and K, obviously the nitrogen, they say that we're good over here on Yard Mastery. I took this, remember, before putting my protein out is when I took this soil test. I did not want to do it after protein. I did it before we put down fertilizer. So this is what my yard is at going into spring. So not a bad soil test. I think I'm really happy with this. The confusing part is the iron. I don't want to go put down iron because Yard Mastery tells me to, and over here they're like, dude, you've got way too much iron. I would lean towards maybe it's in the middle. Maybe we're in the optimal zone. We'll take the low and the high, and maybe we're somewhere in the middle. I don't know.
Well, I mean, I'm sorry he's confused. I mean, or not confused, I mean, he's confused. He's saying he doesn't know what's going on here between these two tests with iron. Iron is, I mean, from a pragmatic perspective, it's actually quite simple. Okay, if you have some sort of concern about color or whatever, and with your turf in terms of iron, just spray out some soluble iron, about 1 to 5 pounds of iron per acre, not per 1,000 square feet per acre. Anywhere between 1 and 5 pounds of soluble iron per acre is going to get you a color response in a very short time frame, probably a day or two. It's going to last probably until you mow it off. Okay. So don't worry about, that's the reason I'm saying, don't worry about whatever iron's in the soil. If you're going to go out and apply, what are you going to do? Take this test and say I'm low in iron. Now I'm going to go to apply iron with my granular fertilizer. I'm going to put it in my fertilizer. It's useless anyway. I have 2 or 3 articles on that. I have 2 or 3 episodes showing that granular iron, even if it's chelated, at least if it's EDTA, is not going to be that useful. In fact, never. We've never actually seen a turfgrass response to granular applied iron. At least through my work, I know there's one article in the literature that showed one little blip on the radar at one rating date. This was, 30, 40 years ago, but so it's possible under very unusual circumstances. But you wouldn't apply granular iron anyway. You would apply foliar applied iron because you would circumvent the soil oxidation process. The iron would sit on the leaves. It's either going to oxidize on the leaf surface, giving it the appearance of a darker color, or some of it's going to be absorbed into the leaf and actually, naturally turn the grass greener through the processes that occur in the plant. Either way, it's going to turn the grass darker green or darker color, but as long as you apply it to the leaves. If you apply it to the soil, you're wasting your money. I'm just letting you know. It's in a very, very, you could do EDDHA, which is usually a liquid anyway, but you could do that. Oh, that reminds me, I saw a video where I think it was these My Soil people. They had an iron study on a video, and they were spraying out iron. And then I don't know if they spread out iron sulfate or if they sprayed it out, but they sprayed out iron sulfate and iron EDHA and iron oxide and all these other things. And they did urea and ammonium sulfate and some other stuff. And they were trying to show the differences between these. Don't do that, okay? Please don't do that. One, he has one replication. You have no idea what's going on in terms of any sort of variability. But 2, you're spraying out the iron and then he was watering it in because he wanted to see what was happening in the soil. That is an unbelievably expensive way to result in an iron response in turfgrass. Just spray out 1 or 5 pounds of iron on the leaf surface and let it sit there. Come back and water it the next day or something if you want to. You're going to see a response. If you do it in the morning, you'll probably see a response before the end of the day. That's how fast that can work. But don't wash it into the soil. If it's chelated, let's say you use EDDHA, which would likely remain soluble for a while, a couple of weeks in the soil. If it's chelated, that's a very, very expensive way to do that. You could achieve the same result just by spraying it out and letting it sit on the leaf surface for a fraction of the cost. And that's what we showed in some of those papers I published years ago. And I think I have a couple episodes on that. So don't worry about iron in the soil on the soil test. If you are worried about iron, just spray out some iron and move on. Worry about something else. Worry about your water. Worry about sharpening your reels or something. Do something, that's worthy of your time besides worrying about iron on a soil test.
The rest of it, we're pretty good. Obviously, we don't need any phosphorus, and our potassium, we had been putting down potassium, not this way back in the, the early, almost a year ago now, and it's saying we're optimal. It says we're a little low over here. Over here on the Yard Mastery, it says we're even a little low, but I think we're fine. I don't think we need to add into that anymore. So overall,
well, good. I'm glad you had that position. Don't apply it anymore. I mean, at 72 parts per million, you're almost no chance of seeing a turfgrass response to that application. I doubt you'd see a negative response to applying potassium at that level, but your risk goes up. When you already have enough potassium in the soil and you continue to apply more potassium, your risk of disease occurrence will continue to increase. So you have enough, don't worry about it.
Overall, guys, comparing the two soil tests, pretty similar. There are differences. Again, the results came pretty much the same time in 5 to 7 days, same cost, but there are some things that are different here that make me scratch my head with the sulfur, with the iron, with the manganese and some of these other things. And then obviously they give you recommendations over here. It's recommending stress blend for my yard based off the soil test from Yard Mastery. We went with protein, so we're not going to do stress blend. And then liquid, it's saying green start, microgreen. So it's recommended more iron with that microgreen, but I'm not going to do that.
I don't know if microgreen, is microgreen a granular product, guys? Is it microgreen granular or is microgreen foliar? I don't know. If it's granular and they go, oh, well, it's granular, but it's chelated. I don't care. Doesn't matter. I have done, I don't know how many studies with iron. I want to say it's like 14 or 15 studies. I can't remember. And I've published maybe, I don't know how many I've published on that. 3 or 4 or 5. So I don't remember how many studies I published on it. And not once did we ever see a granular or turfgrass response to granular iron applications. Whether it was chelated or not, didn't make a difference. Whether it was applied at 0, 5, 10, 20 pounds an acre of iron or not, didn't matter as a granular. It's irrelevant. You have to understand that the rate of oxidation of iron in arable soils is minutes, not hours or days or weeks, minutes. Okay. Even if it's chelated and you have a very, very high pH, then there might be an outside chance that potentially you could see something if you have a pH of like 8 or something. It's, possible, but still it's unlikely because you got to get that rate so high that you're like, well, I can apply 20 pounds per acre or 50 pounds per acre of EDDHA and wash it in the soil and might see a response, or I can apply 1 or 2 pounds per acre and spray it on the leaf and just let it sit there, and I definitely would see a response then. Which one are you going to choose? Just use some economic sense. So my point is the soil iron level for a practitioner, I don't see the point in it. I just don't see the point.
That, as you guys know, we're spraying less this year. Thanks for looking at the soil test here. Let's close.
Okay, so closing it off, he's comparing two soil tests. One is the heliocentric model of the Earth, a valid approach to science, and one is the flat Earth model, and a completely invalid, non-evidence-based approach to, celestial dynamics. Okay. So you're comparing apples and oranges. It's like, I don't care if they're correlated or not. It doesn't make any difference to me. One's valid and one's not. So please stop doing that. Don't try to correlate these two and or even two valid ones. Okay. Which is what I'm going to show you on a PDF right here. There's valid soil tests that can be correlated or not correlated. It doesn't mean either one of them is useful or not useful. It just depends on the situation. If you have a soil pH high enough to warrant the use of a more appropriate soil test for that soil pH, that's all that matters. Well, I have Mehlich 1. What would be my Mehlich 3? Just if you want to know that, then do a Mehlich 3. Okay, you're trying to correlate and convert things over from Olson to Mehlich 3. I just don't think that's wise. So on that note, we're going to look at a couple of papers just real quick, real briefly. And because some of this work's been done, this particular paper is called The Evaluation of Mehlich 1 and Mehlich 3 Extract Procedures for Plant Nutrients in Acid Mineral Soils of Florida. Okay, a lot of people, for some reason, who don't live in Florida, think that Florida soils are neutral or alkaline. That's not true. The majority of soils in Florida are acidic. And this was conducted by a professor, not a professor, I'm sorry. This was conducted by the soil chemical soil test lab manager, whatever his name is, Rao Malavarapu. Anyway, I'm not going to read through this whole thing, but I'm going to go down here and just show you guys what can happen between these two test extracts. Here's, for example, on the screen, a correlation between malic 1 phosphorus and malic 3 phosphorus. This is a regression, I should say. And you see the R squared is 0.64. Okay. 0.64 out of 519 samples they used. They only had an R squared of 0.64. Both of these tests, malic 1 and malic 3, are perfectly valid tests to use. Okay? There's been correlations done on the plant response to malic 1 and plant response to phosphorus from malic 3. There's been plant response or correlations done on both those. But when you try to correlate these two tests specifically, sometimes that doesn't work. 0.64, this is in the lab. So this is not in the field. Field work at 0.64 R squared is pretty good. This is in the laboratory. We're looking for something much greater than 0.64. There's clearly a relationship here by 0.64. But this is not what we would have a lot of confidence in. Granted, the p-value is less than 0.05, but less than 0.01. But it's still only 64% is what we're looking at here. And then we go to the next one. We look at potassium, malic 1 and malic 3 for potassium. And we see a much stronger R squared, 9.7. That's what we're looking at for laboratory data. So malic 1 and malic 3 for this particular soil is essentially a 1-to-1. That's what I've mentioned on some of the other times I've mentioned on other episodes where I said I know this particular soil has had a correlation and it's essentially a 1-to-1. It comes from stuff like this, where this equation here is essentially a 1-to-1, essentially. Okay. And it's an R squared of 9.7 with a p-value of 0.05 or less, or 0.01 or less. And here we go with malic 1 calcium, malic 3 calcium. Okay. And we see a 0.74. And these are tests that are valid tests, not very good in the lab. We have malic 3 and malic 1 magnesium. Here's magnesium. And we see an R squared of 0.83. It's pretty good. I mean, it's not bad. I'm just saying that there's still a lot of error involved with these tests, even if they're valid tests. Zinc. Here's zinc, an R squared of 9.2. Pretty good. Copper, R squared of 8.7. Not bad at all. Okay, and when you see, what's the next one? Manganese. Manganese is really the one that's the worst. Manganese, 0.55 R squared. Really horrible relationships between malic 1 and malic 3 manganese. Okay, and so you can go through here and see boron. Boron's 0.75. So you can go through here and see all that stuff you want to. This stuff's been done before, and they, because some people do want to convert one to the other. And I would just say it can be done if you have work done like this and you have an equation to make that conversion over. But there's still a lot of variability. Here's an extension publication from University of Florida from the same authors, Raul Malavarpu, my buddy Tom Obriza, Kelly Morgan. I think he's either a chair now or something. I can't remember where Kelly is. George Hockmuth retired. Alan Wright's awesome. These guys are all really good. Okay, and then it's essentially extension publication from what we just saw, where we see correlations between malic 1 and this is oxalate iron, and this is malic 1 aluminum and iron, and you see R squareds of 0.84 and 0.62, both very valid, but they're not well correlated. Go down here, you see soil test phosphorus for malic 1, soil test phosphorus for malic 3, and you see an R squared of 0.83, and you see the scatter on this chart here. They're really all over the place here on this particular correlation. You can see so if you get malic 1, you say, well, I need to know what my malic 3 would be. Well, it could be 30 or it could be 100 on malic 3 if you're at malic 1. That's what I'm trying to say, is that the relation, the variability is tremendous. It could be anywhere in this range. And these are both valid tests. That's what I'm trying to tell you. With potassium, it's always really strong, 0.93. So you see that. There's another one called at Ohio State. We know we have a lot of people up in Ohio. And on Ohio State's done some work on this as well. And this particular PDF is called Converting Between Malic 3 Bray P and Ammonium Acetate Soil Test Values. And they have on here some values that if your Bray P is, say, 1, you would multiply it by 1.35 to come up with malic 3 phosphorus. You say, well, how can they do that? If it's ammonium acetate potassium, you multiply by 1.4 to come up with malic 3 potassium. Well, how can they do that? Well, they've gone through here and determined what the relationship is in Ohio soils. Bray 1 phosphorus versus Bray 3 phosphorus, and you see there's a strong correlation there. Okay, and down here you'll see, where's the equation? I don't see the equation on here. Malic 3 phosphorus and Bray 1 phosphorus, and you can see there's some variation, but there's a pretty good strong correlation between those two extracts on Ohio soils with what they've done. And you can see, here's the table you can use to convert from one to the other in Ohio soils. It doesn't mean you should take that into New Jersey or Montana or Florida and start using these conversions. That means for the Ohio soils that they tested, you can use these to do a conversion. Okay, here's potassium with ammonium acetate and potassium with Mehlich 3. A lot of variation here. I don't know what, again, the R-squared is probably pretty strong, but there's going to be a lot of variability on that one as well. And you can just go through here and see. Okay, you can see all the ways in which they've correlated these before. And the point is, even on tests that are known to be sound evidence-based tests, there's a great deal of variation between one extract being Mehlich 1 and the other one being Mehlich 3. And these are valid tests. So imagine taking a valid test and trying to correlate it with one that is not an evidence-based test. Don't do that. They could be dead on, and you might just get lucky and pick the right number of gumballs, or they could be completely not correlated, and in fact, the other test could in fact be true. In other words, there's a lot of unknowns there. So until these, I don't know, control myself here, but until the researchers who are promoting this nonsense spend some time to actually do a proper correlation and calibration with that ion membrane test, not the ion membrane test that they're using. Until they do that, there is absolutely no good reason to spend a penny on those tests. None. Okay? Until then, save your money, use a valid soil test. You can use some of the home test kits like soilkit.com or that RX Soil. They appear to be valid soil test kits, and you can do it at your house. Or you can mail it in, right? Or you can do it through the extension office in your state. So either one of those, any of those are fine. But please refrain from using those membrane tests until they take the time to actually do the work and determine whether or not there's a correlation. And then even if they do find a correlation, the correlation better be stronger than the correlation we have with Mehlich 1 or Mehlich 3 or Bray or anything else. Because if it's not stronger, then there's still no good reason to use it. There's still a better reason to use the traditional extraction methods. Okay, guys and gals and everybody else. On Thursday, I'm going to go over Thursday evening, I'm going to go over some comments and emails, and I'm going to go over what is now the first, comments and emails. So people send me some hate emails and some hateful comments here and there. I'm going to go over those at the end. But I got the first hard mail, snail mail, right here. Okay, I'm not going to show what the other side of it is. It's just some nonsense marketing. It's not a letter to me in terms of any hateful comments, but it is a marketing. Somehow I got on someone's marketing list. I don't know how. They actually sent me a hard copy of some nonsense. So I'm going to go over that as well. I thought it'd be appropriate to go over whatever they're sending me, whether it's in hard mail or regular mail or email. So let me answer any questions. If you have any, throw them in the chat and I will answer them before I go. It says, Gray says microgreen is a foliar. I'll say, so if it's a foliar and has iron in it, there's an extremely good chance you're going to see a good response from an application as long as it's at the right rate and the right time of year. And Randy says, is there any research on how you can solubilize iron from the soil with some weak acid like citric, for example, or still the oxidized iron will be solid? Well, that is an unbelievably difficult question to answer. I will say that the iron in the soil, all iron in the soil is dominated and controlled by iron oxide, essentially. So it's constantly being oxidized out of solution and occasionally being reduced back into solution through a number of variables. And I am not knowledgeable enough to be able to answer that question, Randy. I'll just say that. I will say that it is very possible. Well, actually, it happens all the time. Iron gets released back into solution all the time through around the rhizosphere. Okay. That does happen. And it is possible to happen in high organic soils where the organic ligands will have an influence on reducing the iron back into solution. But whether or not you can add something like a citric acid and in turn solubilize some of the iron back into solution is, I don't know. I don't know any literature on that. That very well could be the case. But my question back to you, Randy, would be, why do you want to do that? And if you have a valid reason to do that, the next question would be is that the most economically sensible method to apply iron or to alleviate an iron deficiency in your turf grass? Applying citric acid generally isn't very expensive. The question is, the response from that sort of program, applying citric acid to solubilize iron back into solution, might have a response. I'm not saying it wouldn't. But you need to compare that not to nothing. You need to compare that with applying foliar iron sulfate or a foliar iron chelate or something like that. Which one of those two would give you the response for the money that you spent on it. That's the approach that I would take on that, Randy. Okay. It wouldn't shock me at all if there's some literature showing that an acidifying compound like sulfur, for example, or citric acid, for example, it wouldn't shock me at all if that resulted in some reducing of the iron back in the solution. That's very possible. I'm not aware of it though. Okay. 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 All right, guys and gals. I'll see you on Thursday evening for the 1 year anniversary comments and email show. Thanks a bunch, guys. Gals. See you then. Bye.